Hey everyone, welcome to our data analysis Microsoft Excel webinar. So we are going to look at data analysis in Microsoft Excel. This is Beyond Data Statistics Solutions, and our partners are Regression Initiative. So our aim today is to look at data analysis in Microsoft Excel. So you have to ensure that the analysis toolpack is active in your Microsoft Excel add-in program. So I'll show you how to enable that in Microsoft Excel. And then I'll also be able to give you the foundation of regression analysis, that is linear regression analysis. So linear regression is a statistical approach to modeling the relationship between a scalar variable y and one or more exponential variable denoted as x. So it can be used for prediction and forecasting. And when you look at multiple linear regression model, or the regression model in general, is y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus up to beta n xn plus an error term. So y stands for the dependent variable, beta naught stands for the intercept, and beta 1 x1, beta 1 stands for the coefficient of the variable x1, beta 2 stands for the coefficient for the variable x2, and so on and so on up to beta n, the coefficient for the variable xn. So from there is where now you can have either a simple linear regression or a multiple linear regression. So in simple linear regression, this involves only one independent variable. So you are predicting a dependent variable y against a single independent variable x. And now this is the model equation for simple linear regression, which is y is equal to beta naught plus beta 1x plus the error term. In multiple linear regression, this involves the following equation with two or more independent variables. So that's why we have this model here. Y is equal to beta naught plus beta 1 x1, beta 2 x2, up to the number of variables that you can include in your model. So let's look at a case study of a regression analysis in Microsoft Excel. So a case study of multiple linear regression in Excel. All right, so just delete this. Important for us. We go to the regression analysis in Microsoft Excel. So we want to look at our case study. We compare it with what we have here. So in our case study, is about predicting patient recovery time. So we have predictor variables as follows: age, pre-surgery health score, post-surgery physical therapy duration, and medication adherence of the patient. And then the outcome is the recovery time. So the age is the age of the patient in years. The pre-surgery health score is a score indicating the patient's overall health before surgery. That one is obtained using the standard health assessment scale. And then the post-surgery physical therapy duration. So the post-surgery physical therapy duration, this involves the total duration in hours of physical therapy sessions the patient underwent after surgery. And then the medical adherence, this is a score indicating how well the patient followed the prescribed medication regimens. So this is a scale of 1 to 10. And then the outcome variable is the recovery time, which is the number of days it takes for the patient to fully recover from the surgery. So let's go to the analysis in Microsoft Excel. So here is the Excel. So in this Excel, I want to carry out, let me start by carrying out a regression analysis. For example, simple linear regression analysis, where maybe we want to predict the recovery time of someone from surgery, maybe based on their age. So can we say that there is, which kind of relationship, can we say that age can be used to predict how long someone can take to recover? That's what simple linear regression is about. So for you to be able to carry out that in Microsoft Excel, you have to go to your data. So we said, first of all, when you go to your data, check if your Microsoft Excel has data analysis toolbar here. So if it is not there, you have to go to files and then options, files and then options. So you go to files and then you go to options, and then here you go to add-ins, and then here you go to analysis toolpack, and then you click go, and then check the analysis toolpack here, and then click OK. Once you're done, you'll be able to see the data analysis here. When you come to data tab, you'll see data analysis. Right, good, everything fine. Okay, so we start by carrying out a simple linear regression. Let's see how we carry out simple linear regression in Microsoft Excel. So you come to data analysis toolbar, and then go to regression, and then click OK. So here, let me just remove the default data that is here and explain everything one by one. So we will start by inputting the y. The y is the dependent variable which we want to predict. So we want to predict the recovery time. We are carrying out a simple linear regression. So we want to predict recovery time based on age. Based on age. Can we say that age can predict how many days someone can take to recover from surgery? And then we select this is just a sample data, not that it is truth to make a decision out of it. This is a sample data, so we are using it for analysis purposes only. So you confirm the level of significance, it's 95%. Yeah, so after you have that, you can output your results. So output your results. Yeah, so when we get our output of our results, we get a summary analysis here about our simple linear regression. So we start with the multiple R. This shows the correlation between the two variables, the reaction time in terms of days and the age of an individual in terms of minutes. So there is a very positive relationship. That means that as the of number of age of someone in years increases, the number of days for recovery also increases. That's what this data is telling us. So we have R squared and adjusted R squared. So we'll go and use adjusted R squared because it has removed some errors and noise in our data. So we are not using the R squared, we use the adjusted R squared. So this one tells us that age can predict or can explain 91 I just delete this one, delete all this output. Yeah. Sorry for that. Let me just check. Where is it highlighting? Okay, it's highlighting here. So let me just delete everything. Yeah, so let me just cancel that. Yeah, like that. Right click, delete columns. Again, delete columns. Okay. Okay. So we want to carry out multiple linear regression analysis. So in multiple linear regression analysis, let's see how we can do that using the data we have here. So you go to the data tab. So click here, regression analysis, click OK. And now you provided the selection of the area. So you select here the y-axis, the dependent variable, and then here you select the remaining data, the remaining full data. So here you must provide the full data for the other variables, because we said in simple linear regression you only consider one variable. So like that, you check like that, output range, you select the output range is that one, and then you click on OK. And yes, so here you have the output for the multiple linear regression. So you also look at the fit, the strength of the relationship between all the variables with the predictor is a very strong one, approaching 1. When you look at how to interpret the correlation, we say that in a correlation, a value with -1 indicates a negative relationship between variables that are in the question. A perfect negative relationship. At 0 means there is no relationship between the variables, approaching to 0. And then 0, no relationship. Relationship decreases as you approach to 0. When you approach to 1, the value is perfectly positive, strong positive relationship. We said we are not using the R squared because it is not, the errors are not removed. So it's the adjusted R. The adjusted R shows as the percentage in which the value, our variable, dependent variable has been explained by the present independent variables. Yeah, so that is it. And then we go to the interpretation. Yeah, so this is the interpretation of the data. And yeah, these are the coefficients. So you can be able to model actually the relationship and be able to predict here. So let me show you how you can be able to predict with what you have. So we say we want to predict here, here, we want to predict here. So you say you provide the value here that maybe you want to predict, maybe how long will, okay, you provide the age, sample age, maybe 45 years. What will the reaction time, the recovery time for someone with the 45 years, someone who's this is the pre-surgery health score is 7, and the physical therapy duration in hours, this person has had 20 sessions for physical therapy, and the last part is medication adherence score. So this is from 1 to 10. Maybe this person adhered 7 out of 10. And now what will be the reaction time? What will be the recovery time? Sorry, the recovery time for this. So we'll say equal to, and then we provide the intercept. Remember in our linear regression model, the intercept, the beta naught is this one, plus beta 1 is this one, multiplied by the variable age. This is the variable age. Yes, the new age you want to predict, plus. Remember, there is a minus here, so it will cancel this plus the coefficient for the variable pre-surgery score times the pre-surgery score times the pre-surgery score value. You see, plus the physical sessions that this person had, the coefficient for the physical sessions. But this one, you see, when you look at its p-value, it is not significant. So you can remove it from your model and be able to analyze the remaining ones to be a very perfect fit. You can be able to do that. So you input the physical therapy sessions, and then you multiply by the value. This is the coefficient multiplied by the value of the therapy session, the new value for the therapy sessions. And then plus. And then you multiply by the coefficient for the medical scores. And then you multiply by the variable value of the variable medical scores. And then you hit enter. You'll have predicted the new. Now that's how the multiple linear regression works. So you see, you have been able to predict that a person who for 5 years with the pre-surgery 7 score out of 10 and had 20 hours of physical therapy, and also the score is 7, the adherence score to the medicine that was prescribed is 7, can take 17 days to recover. That's how we use multiple linear regression. That's how multiple linear regression is very sweet. Okay, now we go to one sample t-test. So let's go to the presentation. Yeah, so that's how we have been able to interpret that. So when you look more on that, you can be able to understand. So here now we are looking at the hypothesis testing. So hypothesis testing, we have said that there are two types of hypotheses: the null hypothesis and alternative hypothesis. And then we have two types of tests. That's one-tailed test and two-tailed test. So, and then we have type of errors in hypothesis testing. So have type 1 error. This is due to the rejection of the null hypothesis when it is true. Rejecting the null hypothesis when it is true, you'll have committed type 1 error. You can look at the contingency table here, the cross tabulation table. The correct decision is when we reject the null hypothesis when it was supposed to be rejected, what we call as when it is false. And then when we do not reject the null hypothesis when it is true, that is also a good or a correct decision. And then another type of error which call error of the mean. Standard error of the mean. So I can just put this in the bracket to make it look good. Yes, it should be like this. And then divided everything, divide it by the standard error of the mean. That's how you compute the test statistic. So sample mean minus the hypothesized mean divided by everything divided by the standard error of the mean. Then you have there your test statistic, and now you can compute the probability value. Is usually computed by using a t-dist function in Microsoft Excel. You can be able to compute the probability value. So you take x is the t statistic you obtained, and the degree of freedom is this. You have it here. The tail. So for our case, we are testing a two-tailed test because we have said it's one-sided or two-sided. So we are testing a two-sided. So you choose two, and then you close your function in Microsoft. So you'll be able to compute the p-value. Should be able to compute the p-value. Sorry about that. Let me just check if everything is fine here. So f the degree of freedom district, the degree of freedom divided by this degree of freedom, and then it is two-tailed. It's two-tailed. Degree of freedom, then it is two-tailed. Yeah, it should be able to give us an answer. Should be able to give us an answer. Let me see. The degree of freedom is f2. Yes, and then the tail is two-tailed. Yeah, should be able to give us an answer. Should be able to give us an answer. Okay, so that's how we do that test in Microsoft Excel. So we usually compare this value with the probability value. So let me just check the error here. Number error. Okay, okay. Let me just check the number error. So what I can do, I can just provide this value here, negative 1.48123. Yes, and then can just refer to that value here, t distribution, and then I refer to it. The degree of freedom is 9 and 2. Yeah, so there we go. So it was just a slight misunderstanding in Excel about the function. Yeah, but now if it fails to refer it from here, because this is an expression, so you can be able to just write that value on somewhere else and then be able to output that. Yeah, so that's it. So that's how we obtain the p-value. So we compare this p-value with 0.05. We compare this value with 0. What we are doing is we are checking if 14.3 is different from 15 from the hypothesized mean. That's what we are doing. That's what one sample t-test is doing. It's comparing the inches, that the sample mean is different from what the farmer had hypothesized. That's what it's doing. So when the p-value we obtain here is less than 0.05, we reject the null hypothesis. The null hypothesis H naught was that the means are equal. The means are equal. The means are equal. The means are equal. That means that 14.3 is equal to 15. And then H1 is that the means are not equal. As simple as that. H1 is that the means are not equal. Means are not equal. Yeah. So we will reject the null hypothesis if this value is less than 0.05. In this case, this value is greater than 0.05. So we fail to reject this. So these means are not different, statistically different. They are not statistically different. When you look at it with the layman, you may see that 14.3 is not equal to 15, but statistically they are not different. That's how we test hypothesis relating to this scenario. And then we move from there, we proceed with the presentation. That was a case study, very interesting case study. And then the two sample t-test are independent t-test in Microsoft Excel. So we use the t-test for independent samples when we want to compare the means of two independent groups or samples. So we want to know if there is a significant difference between two means. We have the assumptions, the data must be normally distribution and population have equal variances. That's what we will be going to choose when we will be doing the analysis. So some of the applications of two sample independent is that we would like maybe to compare the effectiveness of two particular painkillers in health industry. So a group of people are given one drug, drug A, and another group of people are given drug B. And now we want to compare their means. That's the effectiveness. We want to compare the effectiveness of the drug, the two drugs. Maybe we are measuring the body counts, maybe the immune count of the white blood cells in this case, maybe. And we want to see if there's how many antibodies and things like that that relate to the health sector. Yeah, so comparing treatment effects in medicine. Yeah, for example, you want to test yeah, the two drugs, which one is effective, the treatment procedures and the effects and maybe the side effects of a particular drug. So some people are given a particular drug, others are also given a particular drug, a different drug, and then you are testing, checking the effects to the people. We would like to compare the study hours between female and male students if they differ. So here we can also be able to check if male are performing better than female. Can we say that male perform better than female? So we can use independent sample, two sample t-test to perform that. We can also be able to, would like to compare the effectiveness of two procedures to know which one is the best. This one is more into the manufacturing area where we can be able to use the two independent sample t-tests. So we use one procedure, we see how many products we are going to have. Another procedure, how many products are we going to have? Then we choose which procedure is better than. Can we say that this procedure is better than the other? Now we test the hypothesis. It's actually basically about making decision. Testing market campaigns. So we use one campaign to do marketing. We see what is the return on investment. Then we do another marketing campaign. We see the return on investment. Then we compare the two. Which one is more effective? So we use the two sample independent tests to do that. Studying consumer preference. Yeah, what are some of the preferences that our customers do have on our products? You give them one product, you give them another product, and see what are their preferences. Can we say that majority are interested in taking this and not the other one and stuff like that? Comparing sports performance, this you can compare teams or you can compare even the players. A case study in this scenario is about a car hire company. And we do the same, follow the same procedure on the way we conducted for the t-tests, but now we choose paired sample t-tests for means. You click OK, you select the range, you provide the range for your data. My data, I select the data like this, and my data has labels. And then I also select here test 1, and then I select test 2. Yeah, so this is the wrong one. This is the wrong one. So we select test 1, test score 1, yeah, like that. And then alpha 0.05, the same way we just did in the other scenario. And then we select where we want to see the output. Then we click OK. So you'll see the same table similar to the previous one, but in this one, you will only see we are just going directly. So we are comparing if 74.3 and 79.3 are different. So we look at the p-value for the combined p-value, and this value is actually less than 0.05. So we reject the null hypothesis. The null hypothesis is that these two are equal. There is no difference between the students going to the library and not going to the library. So we rejected that one. There is enough evidence based on the p-value we have obtained here, because this value is less than 0.05. And up to that point, I end this presentation. Thank you so much for attending the data analysis workshop. And this is just part of the post-training recording. Thank you.